Now, some pollution just happens. Whatever gets spewed into the atmosphere, that causes the pollution. Other pollution is, as mentioned before, due to chemical reactions that occur, right? So, chemical reactions, it's a process where we have one set of chemicals converted into a new set of chemicals. And so, we describe these with our chemical equations. All right, so here I have a pictorial view of what happens in a car engine with one of the components of gasoline. So octane is a hydrocarbon, octane, octate, all right? And so octane gets burned in oxygen, it undergoes combustion, and outspews carbon dioxide and water, all right? Now, this is not a very convenient way of representing a chemical reaction because it's a lot of drawing, a lot of balls and stuff, and then it's hard to balance it. So we like to write things more symbolically like this. Okay, down here I have another combustion reaction. This one's propane. So if you have a propane tank, when it undergoes combustion, we get this reaction right here, and it is balanced. Water is formed from hydrogen and oxygen, and so I would have some hydrogen gas. I'd have oxygen gas, and I would get, and usually it's done at a high heat, so initially it's going to be water vapor, and then you can condense it down into liquid water. Now, we do have to balance our chemical equations, all right? And so this is not balanced up there because I've got 2 hydrogens and 2 oxygens on my reactant side, and 2 hydrogens and just 1 oxygen on my product side. So this one actually balances out like this. Okay, so on the left-hand side, these are reactants. And on the right-hand side, you get your products. There's all sorts of different types of chemical reactions. Sometimes you have multiple reactants in a single product. Other times you have multiple reactants and multiple products. Sometimes you have a single reactant and multiple products. So all sorts of different types of reactions. Okay, so here I have another view. So we've got some hydrogen and nitrogen that react to give us ammonia. So here again, there's our nitrogen and hydrogen, our reactants. And then we get 2 ammonia as our products. Okay, so reactants yield products. So some important symbols. So in parentheses, we put the state of matter so that we know what state everything is in when it undergoes a reaction. So we use G for gas, S for solid, L for liquid, and this AQ, which stands for aqueous. And what that means is that it's a substance that has been dissolved in water. Okay, so AQ stands for aqueous. Okay, now again, we have to balance, okay? We need to satisfy the law of conservation of mass. So we're talking about an ordinary non-nuclear reaction. Whatever we put in needs to be what we get out. All right, so the mass of my reactants needs to equal the masses of my products. The total number of each element on my reactant side needs to equal the total number of each element on my product side. So when I look over here at that ammonia one again, okay, I've got nitrogen and hydrogen. So this 2 that's subscripted next to the nitrogen, that means there's 2N, so 2 nitrogen. So I'm going to take a ledger here. So I'm going to have 2 nitrogen. Now I have 3 H2, which means I have 3 H2 molecules. Okay, H2 means there's 2 hydrogens. If I have 3 times 2 hydrogens, I have a total of 6 hydrogens. Okay. Now, when I look at my ammonia product on the other side, I have 2 NH3, meaning I have formed 2 ammonia molecules, all right? So there's only 1 nitrogen. There's no subscript there, so an implied 1. So 2 times 1 gives me 2 nitrogen. And then I've got 3 on my subscript on the hydrogen, so 2 times 3 gives me 6 again. So 2 nitrogen equals 2 nitrogen. 6 hydrogen equals 6 hydrogen. Okay, and so we can go through all of this. If I count out the masses involved in this particular zinc reaction, I end up with the mass of my reactants equals the mass of my products. Okay. And then here's a picture of magnesium burning in oxygen, giving us magnesium oxide. And so you can see I have 2 magnesium. Okay. O2 means I have 2 oxygens, and then 2 magnesium oxide, 2 magnesium, and then 2 times 1 for the oxygen, 2 oxygen. Okay, so if it is a coefficient in front of something, it populates out to the whole thing. If it's a subscript on something, it just belongs to that. All right, so when we do our balancing, if we have it written in words, we would use our nomenclature and we would translate that into a skeleton equation. And then we would balance the atoms, adjust our coefficients, and double check. All right, so when you start off with this, it's totally fine to keep a ledger. All right, so when I start off here, I have phosphorus, chlorine, hydrogen, and fluorine. So I have 1 phosphorus, I have 3 chlorine, I have 1 hydrogen, I have 1 fluorine. On the other side, I have 1 phosphorus, I have 1 chlorine. I like to write them so that they line up. I have 1 hydrogen, and I have 3 fluorine. All right, so my chlorine and my fluorine are not balanced. So let's see here. What would happen if I put a 3 here? Okay, that would change this to a 3. Okay, now that balances the fluorine, but now it unbalances the hydrogen, but I still don't have the chlorine balance. So what if I put a 3 here? Oh, well, that gives me 3. That gives me 3. Oh, now everything balances. So I get some phosphorus trichloride, 3 hydrogen fluoride, yields phosphorus trifluoride, and 3 hydrogen chloride. Okay. All right. And so I have a few others for you to practice. All right. So I want you to practice these. I've got this slide and one other slide, which if you downloaded the PowerPoints on Canvas, they're all listed on one slide. Okay. So I actually want you to try these on your own. And then what I want you to do after you practice them, if you want to check if you did them correct or not, I want you to go ahead and email me your answers or submit them through a Canvas message, and then I can check your work. But I really need you to try these on your own because that's how you learn and how you practice. So keep your ledger. And remember, everything has to balance out. All right? So try these on your own and try these on your own. And then send me an email or a Canvas message if you want me to check your work. All right? So that is equation balancing.